Something with the wrong machine. How's everyone doing?
Good. How are you?
Alive? Always post compilers. I'm the one heating up the room too, making sure that I'm getting everything right. I'll be here teaching till 5:30. Gonna be a long day.
What time do you get here?
From my first class at 9, so I'm usually here by 8 or 8:30, depending on how much work there is to do before class. So we had our client meetings yesterday. Hopefully that was somewhat about what you were expecting from that. I thought they went quite well overall. And posted feedback and associated grades. I think this gives you a little bit of a sense of what I'm looking for out of a client meeting. It's mostly pretend like I'm not there. I am just there to collect notes and to analyze how the process goes, but it should be something that is between you and the client. And I will only provide clarification on an as-needed basis or a really bad joke on an as-needed basis. Yeah.
So for the next lab, since we're not meeting with the client, what are we gonna be doing in that time?
Design period for groups, yeah, so sprint 2 will be underway at that point, and I'll kind of be meeting with every group as I can, just kind of going around and making sure that you're all on the right track, that you all have an understanding of the requirements, and I will be mentioning some additional technical requirements that the client did not mention. So you can imagine that as the project manager, I also heard the client or spoke to the client about their requirements. And I have my own idea of what the requirements are that may be a different version of what I talked to the client than you talked to the client. So you all have an idea of what the functional requirements for the second sprint are. But as the project manager, I'm gonna think and realize that, you know, maybe there are some smart ways to do this. And one of those we're gonna talk about today. And so I will state that one of the requirements for sprint 2 is that your solution now needs to adhere to model view controller, a model view controller design. So we're going to talk about what that is today, so that by the time you start working on sprint 2, you know what you're doing and don't start working on it in a way that has to be redesigned later. So don't worry about this at all for sprint 1. In fact, I do not recommend touching this for sprint 1. Make sure that what you deliver for sprint 1 is just sprint 1's requirements. But you can start underneath the hood as you learn about this. Think about how could I incorporate this into our project? What does that mean for a redesign of this project? Don't go do it. Just think about it. So that when you have a design meeting with your group, you're ready to contribute some ideas. So let's see, we have a sprint deadline this Sunday at midnight. My recommendation, to whatever extent possible, try to avoid working on Sunday night. And that way, when you're working on Sunday night, you're most of the way there. Then we'll have our last peer review for this sprint next Tuesday. And that way, by the time you're filling it out on Monday or Tuesday, it is after the Sunday deadline. So whatever happens Sunday night, that'll be apparent on those peer reviews. There are a couple people that I will be reaching out to talk to about just due to the results of the first peer review. But for the vast majority of you, everything's going just fine. You probably already know who you are if you're one of those couple people. If you've been thinking, I hope I've been doing enough work, you've probably been doing enough work. If you know you haven't been doing enough work, you're one of the people I'm going to talk to. You would have to know for sure. If there's any doubt in your mind, I'm probably not talking to you. Again, only a couple people, and it's only the people who have been not here, not contributing at all, that had significant problems in their peer reviews. That should not cause any, I see that causing more stress somehow. That should cause less stress. It's not you, unless you know it's you. Let's see, and then beyond that, I don't think we have anything super major scheduled in the near future. Just make sure that as you find yourself with a little bit of downtime, especially between sprints, catch up on a chapter of the book. So that by the time we take the next quiz, you're not cramming that information into your skull ahead of the quiz in a way that you will forget.
The client meeting feedback you posted last night on Discord, you posted 3 different scores and then an average score.
Yeah, the average is what, so on the rubric, there's, the client meeting is out of 10. So the average score was just the ceiling of those 3 scores averages. So if it turned out to, 7 point something, then I rounded that to an 8. Even if it was, 7.3, something like that, I just rounded up, whatever it was, rounded up.
It's not the average for like all groups.
Correct. Yeah, it's the average of the 3 scores that you got there. Yeah, I don't share the average of across the groups, because I don't think you should be comparing yourself to other groups in the class. You should be looking at the exact feedback that you got from the client. And I want to treat each one of these meetings as this is its own separate development fork, its own project that the client wants. So that means the individual feedback for your group, you should take into consideration. And even if another group is doing something that's really cool, that might just be a design philosophy of theirs that works well based on the strengths of those group members. You shouldn't be copying each other or trying to make each other's turn your program into a program. I want to see your plan. I want to see your design. And honestly, every group is off to a pretty good start. So I'm excited to. So I think people should continue doing what they're doing. I'm excited to see where it goes. Every year I teach this, it's a different subset of UML diagrams that everyone has different design philosophies. I find it fascinating. Just look at it. Anything else before we dive in? I think that's everything we're concerned about upcoming. We're kind of between quizzes, so everything is on you with the project at the moment and not too much interfacing with the class aside from the new material we're covering.
Sure, quiz Monday. Next Monday.
Let's see, this is week 4, so we're 2 weeks away from the next quiz. I think it was 3, 6, 9, and or is it? Maybe it is. Maybe there is supposed to be something next month. I need to relook at my syllabus. Problem with teaching so many classes and having so much going on is you lose sight of things very quickly. So if there's supposed to be a quiz next week, I should get a study guide to you. I'll make sure to look at that after class. Does anyone know off the top of their head from looking at that? Should there be something next week?
There's.
I appreciate the Jedi wave as well. That worked well.
It does say quiz 2.
Yeah, quiz 2 next week. All right. This is what happens when you get bogged down with other things.
Is it Monday?
No, it wouldn't be Monday. They're always going to be Thursdays.
Okay.
Yeah, so I would not do that to you without a week of a study guide. So even if I missed that, it's always going to be at least a week after I catch my mistake. My mistakes will not affect you more than they have to. I take responsibility for my own mistakes when I can. I'm not perfect. So yeah, that makes sense. Quiz next Thursday shouldn't be, these are not meant to be difficult quizzes. They're meant to be, are you keeping track of the class as we talk about? All right, we're gonna dive into MVC. So we're opening up a unit on design patterns, and I'm handling this a little bit differently than I have historically in this class because some people have taken design patterns, some people haven't taken design patterns. And even if you did take design patterns, I hated that class. I taught it twice. I've heard stories from people who've taken it from people who weren't me, and nobody learned much of anything, regardless of who was teaching it. And I think actually being in a position to apply those design patterns to something that you have created is where that content belongs in the curriculum. So rather than have 212 as it has existed historically, we're going to be roping it into this class where we're going to go over some design patterns at not quite the level of depth that you probably did in 212 or would have in 212, but it's going to turn into more of a bit of a research project. While I talk about what they are and why they exist, of course, there are sources out there, probably sources that you may have seen in 212, that give you code examples of those design patterns that tell you why to use a pattern, what's the benefit that you get, what is the UML or structure, and now that we've talked about UML in this course, you'll be able to read the UML diagrams of those design patterns and have a better shot at understanding what they're communicating. So I think it applies everything that we've talked about in this class. And then as we start to incorporate some design patterns into this project that you are making, you have a way to actually see them applied and work. And then also come back to them later when there are additional requirements and see how those design patterns have led to your program's scalability. So I want you to see the benefit of having applied it, not just a letter grade off of a lab that you did. Yay, you applied it, and the feedback you get is you did well or you didn't. You should see the design benefits of what you implemented in your own code. And I'm hoping that that's what we get here. So the first we're going to cover in a lot more detail, because I'm requiring you to implement it before talking about more design patterns and requiring more design patterns. We'll talk about model view control. And it is kind of an offshoot of a design pattern, but it's considered by most to be one. So we'll talk about it. So very useful for data-driven applications. And our program that we're creating is very data-driven. What data are we storing? Classes, methods, fields that are attached to classes. There's data underneath the hood. Whenever there is data that can change and data that needs to be visualized and data that needs to have listeners out there that are waiting for associated user-driven changes, we can start to take the program and divide it into sections, 3 sections, the model, the view, and the controller, that all work together and communicate together to be able to drive everything that we need from our application. We have a nice way of segmenting them into bins, and related classes and related ideas each go into one of those bins. So if these kinds of apps need to do loading and storing of the data, this makes sense, right? When the user inputs something that is a new class, we need to find a way to store that information. We put it in either an existing data structure or create a data structure for it. There's the user interface, and that kind of exists independently of the data itself. There's communication between them, but until there is an update to the data, the user interface doesn't need to change. Interpreting user actions is also a subcomponent of that. When the user does something with the user interface that requires a change in the data, we can have a component that is basically waiting for instructions and helps the communication between those, the data and the user interface. So the model, the view, and the controller are going to be exactly in that order, dealing with exactly those requirements. Model itself talks to the data, retrieves and stores data. Questions that the model is responsible for asking or answering would be something like, which database table is the requested data stored in? Or which SQL query will get me the data that I need? So it is dealing with all sorts of data access related questions. Data storage related questions. And that's the extent of what the model is responsible for. It's just data. Anything that has to do with data, model should be responsible for it. For the view is your user interface. It needs to query the model for the data. What is the data? What should I be displaying? And it should present it in some kind of format that the user can interact with and or get information from. So now taking this data and displaying it in a human readable, human understandable form. So the view can worry about what text color is displayed. Where are the buttons located? Should this be designed as a drop-down list, a button selector? These kinds of questions are all user interface driven questions that have nothing to do with how the data is actually stored. It's just how the user is going to interact with the program and how the user is going to consume the data stored in the model. How do they actually see that? The controller is all of your listeners. You can imagine that the controller is just this very bored entity waiting for something to happen. And it's constantly looking around like a rodent, waiting for something to happen. When something happens, it gets very excited and runs off and delivers the results of that where it needs to go. So any change in data or state in the user interface, so that means the user did something. If the user clicked on something, there may be some kind of on click in JavaScript, or you can imagine doing something similar in some kind of user interface that just captures an incoming stream of something happened to the user interface. And this becomes the logic of who do we let to need know that something happened? So it's the kind of the interpreter of that button was clicked, model, update this. Data was changed in the model, user interface, update that. Something that is listening for something that's actively going to happen and then making sure that the appropriate changes, that the appropriate method is aware of what needs to change and how. Why use MVC? Code is very well organized. You can start asking yourself, all right, designing the functionality of these new requirements, is it related to the data? If so, I should be writing something in the model. Is it something related to the user interface? If so, I should be looking at the view classes. Ease of development, this means that you can do things like switch out data representations. So let's say that you decide that, you know, this array list that we've been using for our project isn't really the way that we want to store this. I really think that they should be interacting in some other way, shape, or form. If you've designed this well, you should be able to take out the model that represents the array list and put in a model that uses a hash map. And everything else should just function. It should interact with it in a way that that is a piece that can be removed, surgically removed and replaced with no further stitching required in any other part of the program. Similarly, let's say you have a desktop user interface and you want a mobile user interface for someone who's going to utilize your UML editor on their phone. You could load up a different view, not having to change anything in the model or the controller. And if the user is using their phone, just swap out the desktop view for a mobile view, uses the same model, the same controller, and now you have an application that can easily switch interface representations.
So speaking of that, in our meeting yesterday, Tony mentioned that we're supposed to be able to run either the command line version or the UI and version from the command line just with like different flags.
Yes.
You also mentioned something about using like David and Gradle to be able to like double click on application.
Yes.
Can you speak a little bit more of like the actual requirements behind opening the application?
Yeah, so that's the reason that Tony didn't talk about that yesterday is the client has no idea what any of that is. From the project manager's perspective, I will be expecting that there is a build tool being utilized. It's no longer enough to run something in an IDE or even just have an executable that runs it. The reason to use a build environment is to be able to incorporate tests into the build procedure, making sure that you get a clean, all of your tests pass every time you attempt to build your application. So that's really the entirety of that. In terms of the usability of the program, it should be standalone, either runnable from the command line or an executable. I don't really care which way you go about it, but just make sure that when you build it, you are utilizing some kind of build tool like Maven and Gradle. That can be built into your IDE, that is fine, but you're all going to want to be on the same page about which build tool you are using and making sure that it's incorporated. I will state the exact technical requirements for Sprint. That is one of them, as is MVC. I'll give you a full breakdown and list on Monday, because I think you should be focused on Sprint 1 between now and then. But I don't mind giving you a hint or clarifying things to the extent to which it helps you to design Sprint 1.
Or is this, I know it's probably done in many ways, but typically would there be like a parent class that's a view class and several classes under that, so you have a a controller class, a parent class, and the.
Usually they're gonna be multiple classes in each. They're arbitrary dividers between who's responsible for what. So you'll have a cluster of view classes. So they could be the different views. And when you launch the application, if you see a particular flag, then the view that you load is going to be the associated view represented by that flag. Something of the sort like that. For a model representation, maybe you want to be able to store something in a database representation or a local representation that might be based on the associated scalability needs. So you could launch this with a flag that says, I'm just working on a local UML, or I'm working on a UML for Windows, in which case it's going to need to scale and have the associated scalability built into it. So maybe you have different models with different data representations based on the associated scalability needs of the application. But yeah, usually you don't want one class for the entire model because you're going to have a class object and a method object so there are going to be different objects for that you don't necessarily want all in the same file or all in the same class, because that just becomes, you start to need surgical tools to move things around for all the interdependencies from that. You want to separate to whatever extent you can, and then add in some design pattern overlying to that so that you build up making changes as easy as possible. And we'll get into that more when we talk about design patterns. I think that'll help make that a bit clearer. But does that answer your question? I have a hard time knowing sometimes. Anything else? Yeah, so I kind of already I covered the flexibility aspect of this. In theory, model view controller looks kind of like this, in that everything communicates with everything, except the view doesn't really communicate with the model. The model pushes its updates, so when the data representation changes, it will communicate with the view, hey, something changed, you should update your view. And the view and the controller are communicating with each other whenever a change happens in the view. The user clicks on something, changes the associated data, types something like the name of a class and hits enter, like I want to create a new class, enter. Then the controller will hit that enter, say the user entered something. What is it? It's the name of a new class, model, create a new class with these associated parameters based on what the user typed. So in theory, this is what model view controller looks like, is there's actual communication going on between these components. In practice, we find that the view and the controller are so interdependent on each other that sometimes it makes sense to include them in the same files. So really it's model and view controller. If you over design your MVC, you will find that you need to write a method in the view and an associated method in the controller, so that the method named exactly the same thing in the view calls the method that does exactly the same thing. So it's a middleman who basically does nothing. You can imagine a game of telephone where I tell you a secret password, and that secret password is secret password. And you need to communicate it to the next person in line. And you go, it's secret password. What is the point of that middleman? Doing absolutely nothing except parroting what one says to the other. That's kind of useless. And in practice, if you find yourself designing a controller that's just parroting what the view already has all of the information that it needs to communicate that directly to the model, don't use a middle controller for that. You can just pair the idea of the controller into the view. It's only if you need separation of those components where the controller is interpreting what the view is doing in a way that is dependent on which view you are using. That's when you want to have a separate controller. Does that make sense? If there's an aspect of which view you're using and how that view gets that data. So on the desktop view, you would have an on click, and on the touch screen, you would have an on tap. Then there's no reason to have a single controller for that, because now you need to duplicate the methods for each associated view. You would rather just have that controller built into the view so that you're able to put that in the view itself rather than having to swap out a controller for it. But yeah, they end up in practice looking very much like a view and a controller are together. And that is okay to design. So I'm not necessarily looking for exact space in between all three of these components. I'm looking for a design that makes sense. and is scalable. So as you go through a design of what MVC looks like with respect to your application, just make sure that you're critically thinking through, should there be separation here? Should these be paired together in some capacity? How much code duplication am I writing? Just be critical. How the model communicates with the view is also a very intriguing and interesting question. So two different architectures. The first is a push architecture. So we're honing in on kind of this arrow between the model and the view. A push architecture says that data updates are the model's responsibility. The model is going to push the update to the view. When an associated change happens to the model, then the view is notified and the view will update. A pull architecture says that the view is responsible for data updates. The view will ask the model for updated data and update with respect to that. Anyone have any idea of why we would care to distinguish between those? Is there a time when a push architecture or a pull architecture would make more sense?
It's down to just how frequently the data is updated. The data is updated a ridiculous amount of times by the model all the time. You might want also it's not getting all of those push notifications.
Yes, yeah, you can imagine real-time data, something that's coming in with 100 updates per second. Do you really want to give your poor user epilepsy? If the view is updating all the time with all of that new data, it's going to be, what's going on? That's scary.
And on the other side, if the data is fairly static or doesn't get updated very often at all, mom just might want to say, hey, here's an update, spend 5 minutes, so thought you might want this.
Yeah, exactly. The view might say, the weather, for instance, shouldn't be updated on some weather app more than once every couple of minutes. Unless, maybe there's an active tornado or something where things might actually change in a couple of minutes that you might want to be aware of. But in general, oh no, today's high was updated by 0.1 degrees. It's okay if I wait 2 minutes to get that updated information. It's not going to be a life or death situation for me. So I don't need all of that data processing that's going on from the model communicating to the view. You can imagine if you're designing an app that pulls from this, what is the user's phone data going to look like? Are they on a data plan that is capped or their speed gets reduced? And if you're asking for updates, even if those updates are relatively small, 100 times per second, that's going to chew through your user's data. They're not going to want to use your app because they're going to go into their phone settings and see that your one app is responsible for using 90% of their data. So that they always know exactly to the 10th of a degree what the high temperature is going to be today. I think they have better uses for their data. So considerations like that go into the architecture and design of how frequently should the model be communicating with the view, especially if they're not on the same system. So push architecture in general just says whenever the model changes, notifies the view. That means that in some situations, there's going to be lots of communication, lots of updates. In some situations, there'll be just the right amount of update. When an update happens, if it's important, then you should use a push architecture. On the other hand, if it's not particularly important and it should update on a timer or when the user requests it, then you should use a pull architecture. For push, you will always have the latest data. Woohoo! Useful, unless it gives your user epilepsy. For pull, unnecessary updates are avoided, and the view is not spending quite as much computational resource always updating. This will have performance implications on your program as well, depending on exactly what you need this for. So we're going to now query everyone's understanding of model view controller and go into an example. So you can imagine that you are responsible for designing a traffic signal in a busy intersection. You are responsible for implementing the following components. Detecting cars waiting to enter the intersection. The actual lights themselves to direct the cars. Some ability to regulate valid traffic movements. A manual override for lights. The ability to detect pedestrians who wish to cross at crosswalks. The pedestrian signals that direct the pedestrians to cross. And a timer which triggers the change in the direction of the flow of traffic. So you should represent now which of model, view, and controller you would put each of these features in. So go ahead and take some time and, to the best of your ability, make an educated guess about where you would design or you would write the code for each of these features of a digital representation of a traffic signal. People should do this, I think, by themselves initially, and then talk to your neighbors to evaluate any differences in your opinions. And then I'll query the class and get a sense of where do we think these all go. Who wants some more time to think? Couple people, we'll get a little bit more time. Those of you with answers, go ahead and compare them to your neighbors, see if you agree.
Cars, ways to return potential. You. Controller.
I put most of it in control. So it's, control is listed as actual. When you override. That is rate 5. Or detached. I think because there's two parts to it all. There's a movement out to it, and then like the action. So because the going was obviously the mod, and then the action part, you know, to.
I thought.
Regulate traffic controller, that would be the. Because it
Is
listens.
the view tells control like
I'm sorry, one manual override.
controller.
So manual override, I put normal, regulate traffic.
Looks at the cars.
Yeah.
Tells them
Manual
drive.
override.
That's the way, the decision.
I could see why it's a model, because it's a button, but it has the profile and active. So like, that's why it looks a model, it has to do something. I think like the model, it could interact like a SQL server maybe. The data stored, so it only grab information from the SQL sources. Like if you want to. So just source it. Storing, use information, maybe an algorithm or. They store.
Yeah, it's something that counts down, and then once it's done counting, it's going to switch the lights.
Thank you. So.
All right, let's come together and see if we can come to either a consensus or a slight disagreement on where we think these should go. So, detecting cars waiting to enter the intersection. Where do we think that goes? Vote for controller? Anyone with a vote for anything other than controller? View? Okay. So we have controller and view, just to get a sense of who thinks what, or how many think what. Think it's controller? People think it's view? Couple people, so I'm gonna kind of put a big question mark and a little question mark, just to get a sense of.
I built for model.
Okay, I love it. Really small question mark. I can appreciate that. Traffic lights.
Also model.
View, I hear a model.
To check traffic.
Anything other than view?
Water now.
No one thinking this is other, everyone is on board. This is the view and there's no question about it.
I think it's controller.
Yeah?
Yeah.
The second one.
Yeah, the traffic lights to direct traffic, yeah, because,
Lots of people thinking this is view,
it's a change,
a little bit controller.
there's a change going on.
Historically, the minority have been right on some of these. So if you think that it's something other than the vast majority of people, please say it. People have done this before and been right. Regulating valid traffic movements.
Model.
I hear a model and I hear a controller.
View traffic.
People who think it is the controllers. Some people think it's the model. Okay, I think we had a little bit more model than we did controller. We had a good few people for the controller.
Interaction, you're looking at them.
How about manual overrides for lights?
Controller.
Controller, anyone, anything other than controller?
Model.
So kind of, it seems like people are, the majority of people, so controller, it seems like the majority, raise your hand if you think it's controller.
It's controller.
That's not a majority. The view? And interesting, so almost split between model and controller. You say it's the view. Model. People saying controller. People saying model. View.
I think it might actually be view, it's just detecting.
View, yeah, how many say view? All right, so I think we have more A few saying model. How about pedestrian signals to direct pedestrians?
So you,
View,
just information, right?
I'm just gonna put an X here. Everyone says it's the view.
Timer.
External timer triggering changes.
I think it's model.
Lots of model,
Controller.
controller, okay. Who says model? Who says controller? Right, it looks like there was a few more model than there was controller. At least once, the minority is right, again. You ready for answers?
Yes. Controller. Wow.
Okay. Let's talk about it and see why this makes sense. So detecting cars, how do we detect cars waiting? We usually need some kind of camera or something that says there is at least one car waiting for this. So that is going to be some kind of trigger, some kind of event that is going to handle the car entering that needs to signal to the model that there is at least one car waiting. We should probably actually do the trigger that changes the direction of traffic at some point before the person waiting for the light dies of old age. Traffic lights to direct car traffic. Most of you said view, and yes, if you're a driver, you're gonna need to interface with the system. How is it that you're interfacing with the system? You know to go if it is green and to go if you want to die if it's red. Or have a very expensive bill. Regulating traffic movements. These are the actual rules of the system. The rules should be in the data. The data representation is the model. Manual override for lights. This would be something like it's not working and we need to override exactly what the light is. Also to test to make sure that it's working correctly. Yeah.
I actually have a funny story about this. There was this one time I was on Cosa and Wall Street, and this red light would not turn green. And I sat there, I shit you not, for like half an hour waiting for this light that never turned green.
Yep. I had that happen in Billings frequently.
It's actually illegal for you to run a red light that won't turn green.
Yeah. Of course, now you just say, it wouldn't turn green after about 3 seconds because you're an impatient person and like, where is that line? So yes, manual overrides are definitely listeners. So whenever you see the keyword detect or listen or override or this waiting for something is waiting for something, it's going to be in the controller. Because when that wait is over or when that event happens, then there's going to be some kind of communication that's needed to be given to the model and or the view. So yeah, a lot of these end up being controller for that reason. So detecting pedestrians waiting to cross, we're again waiting for that button to be pressed that I would like to cross the street. When that is done, that is an event. And then the controller will handle that event and pass the associated information on to the model to say something like, yes, there's someone who wants to cross in this direction. When this timer hits 0, we should change the direction of traffic. The pedestrian signals themselves, part of the view. How does the pedestrian know that they can safely cross the street? They look at the view, the user interface of the system.
So to clarify, you're saying like model is like basically the goal of what you're trying to accomplish.
It is the data.
Okay, and then like
How does the system work? What are the rules of this system?
the controller is like the hardware that's interfaced with?
It's kind of in between the users of the system and the system.
Oh.
When the user makes a change to the system, the controller says, aha, something happened, interprets that, and then tells the model what needs to be done to change the underlying data representation.
And it was just what, like feedback to the user to that interface with the system?
Yes, because the goal of the system is that a user can do something with it. So when the user is presented the data, it needs to be consumable to the user. So we have to interpret the model's data in some way that is visually pleasing or is informative or digestible.
It's kind of like model view controller.
Yeah. It's the name of the system. It works nicely, yeah.
So, how I'm kind of interpreting this here is it kind of sounds like, view is like output, controller is like input, and model is like, backend.
Think of the controller as like the director. So the view can also take input. It's just that the controller is waiting for that to happen so that it can interpret it.
That's like using a different analogy, if you were making a peanut butter and jelly sandwich, what you're saying is the goal or like the algorithm towards making that sandwich would be the model. The controller would be like the human or the implement you're using to complete each individual task of the sandwich.
I don't know if I would use a task because there's not necessarily data. It's not, it works best in some kind of data-driven scenario.
Well, with the sandwich, you could have a bunch of binary states of is the jelly on the bread, is the bread, is the peanut butter on the bread.
Right,
Pieces of bread together.
sure. That's not really stored somewhere though. That's more of a state-based analysis.
You eat it in your tummy feels nice.
Yeah, your tummy stores the sandwich.
Or the controller being the parent. You don't get one of those today.
You've had too much sugar.
Yes. And the last one is the timer. This one is frequently mistaken, but it is a controller because when that timer hits 0, that is an event that triggers something. So the controller should be responsible for that timer. And when that timer hits 0, it should interpret what does it mean when that timer hits 0. That means as long as the data somewhere has said someone is waiting, either a car is waiting or a pedestrian is waiting to cross that direction, then we should change the direction of traffic.
So
And then the model updates the current direction of traffic.
So bringing it back to like our UML, basically the controller is like, for example, the command line interface part of the program. So when you click a button in the GUI, that CLI part of your program acts as like the controller. Is that kind of what you're getting at?
Yeah, so when you hit enter with a command, then the controller would be the command parser that would say what does the model need to do based on these sequence of tokens that we pulled from the input. Then that would create the associated model method calls that would say the model needs to do this, then this, then this in order to accomplish that.
So the model is like the entire program.
Data.
Per se, like the
Yeah.
entire data structure of the program.
Yep,
And when you hit a button in the GUI is like the
the
view.
view, yep.
And then the intermediary part with the command line parsing is your controller.
Yeah, so when you click the button, what recognizes that a button was clicked is the controller. It's going to say, all right, the button that was clicked was add class. Here is the name of that class. I'm going to pass the name of that class onto the add class method in the model in order to add that class. And that feels kind of like a middleman, like the view could have just figured that out and asked which is why the view and the controller can be kind of related.
So just to clarify, if when you push a button, the controller tells the model what to do and the model knows how to do that task.
Yes.
Okay.
Yeah, the controller doesn't necessarily know, it's the director. It's like me saying, go implement that task in your UML editor.
And the
Do I
model
know
knows how to do
exactly
it.
how your UML editor works underneath the hood? No, but I can give the command for you to be able to go add a class. And you, the expert in how exactly to go do that, will go change your underlying data representation to accomplish the command that was given to you by the controller.
So model is like all the methods, how to do all the stuff in the
Yep.
program, and the controller is basically,
The director.
yeah.
The user wants this, go do that. Does it know how to do that? No, that's over in the model.
So like in a company, like the model would represent like the customer or the program, like someone who wants to do something very specific.
I would say the intern, the one who actually
Yeah.
gets stuff
The
done.
one who gets screwed over and
Yes.
do the thing. And controller is what, like your middle man.
CEO.
Like your middle management. I'm gonna go talk to this person who has no technical information. It only matters because I'm boss, they only listen to me because I'm boss.
Right. And then the view is what your,
Customer, what they see on the outside.
yeah, well, the interface between that and the customer. So something like the advertising agency or someone who is the point of contact for the client. The client.
Controller.
Yeah, right.
It sounds like a major dick.
But sounds like makes a lot of money.
I mean, I do like that.
One more question,
Yeah.
so looks like most of our code would be in the.
User interface, but sprint 2, as you start having a graph, you make this a graphical program, you're gonna be designing a lot of the view.
The view.
Yes, and so that's by design in this class, is that each sprint is kind of focusing on the design of one thing. And now you shouldn't have to do too much to redesign your program because you've mostly written a model, but now kind of putting that off in its own bin and making sure that there's separation between how your data is stored and the graphical representation that you're about to go implement. Those shouldn't be coupled together and tied together because then they're not scalable. If I asked you to come up with now make a mobile view, if your view is tied very tightly to the model, then how do you do that? You have to almost completely remake your program, but if you've separated that, now you can make a second view and load that view instead of this view, and it's way less work.
Knows what you do.
Yeah, as the requirements change, you have structured your code in a way that is less work to adhere to those new requirements. You're kind of future-proofing your code to be ready for that.
And so it's that sprints 3 and 4 will sounds gold and that is that fair.
There will be some change. So we'll be focusing on scalability. We'll be focusing on implementing some more difficult algorithmic concepts.
Okay.
And but I anticipate that because we're focusing now on a model and a view, you will need a controller in order to facilitate the conversation between that.
Okay.
So you will be making the controller kind of as part of sprint 2 as well for that, but yeah, not quite. But sprints 3 and 4 will challenge in slightly different ways.
We're not getting those requirements until Wednesday.
Until Monday.
Monday.
I will make sure that I get it to you by the time, Monday is supposed to be the day that it starts. If you're working through Sunday on sprint 1, then you shouldn't need sprint 2's requirements. Remember that according to Agile, you don't start the next sprint until the next sprint time. You don't pull anything from the backlog for the next sprint. You focus on delivering the best product that you can through the delivery date of each sprint. Right. I'll see you all tomorrow.